This is number 81 from A16. Shows a helicopter lifting a frame and tells us that the whole system is accelerating upward at 0.8 meters per second squared. The helicopter has a mass of 7,650 kilograms. The frame, the sort of half semicircle gray object, is 1,250 kilograms. That means total, our system of the helicopter and frame has a mass of 8,900 kilograms. First thing I'm going to do, they want us to find the force of lift on the helicopter rotors or propellers, then the force of tension in the rope, and then the force felt overall experienced by the frame. I want to say something about the force on the rotors or the propellers. This is an example of third law. As the propellers spin, they push air down. So if you sort of imagine little air molecules, they're getting pushed down. It's just like if you stood in front of a fan, you would feel air being pushed towards you. This is the force of the propeller on air. Just like any set of forces, there's a reaction. And the reaction to that is the air on propeller. So the propeller pushes air down, and the result is the air pushes the propeller up. This force here is called lift. So when I look at the force diagram of the whole system, so I'm going to draw a force diagram for the entire system. I'm going to have lift going up and weight going down. So the net force is equal to, let me erase that. The net force is equal to lift minus W. I'm putting in the negative sign now. So lift minus W. MA, for second law, MA equals net force. I'm sorry, this is really frustrating. Lift minus W. So MA plus W of the whole system will equal the lift force. So this is solving for part A. Put that in here. This is part A. The mass of the whole system is 8,900 kilograms. The acceleration is 0.8 plus 8,900 kilograms times 9.8. And that's equal to the lift. When I calculate that, I got a lift of 94340. That's the answer to A. Part B asks, what is the tension in the cable? So the tension in the cable, in order to do this, I need to look at either the helicopter or the frame. Either one will do. If I look at just the helicopter, its force diagram looks like this: lift, weight, and tension. If I look at the frame, its force diagram is tension pulling it up and weight pulling it down. I'm going to look at the frame. the net force is equal to tension minus W. MA then, using second law, is N minus W. MA plus W equals tension. In this case, M is only going to be the mass of the frame because that's what I'm looking at. This force diagram that I had, T and W, is only the frame. So that would be 1250. The acceleration is still 0.8. That's how much it's accelerating. Plus 1250 times 9.8. That will give us the tension. So if I calculate the tension is 13,250 newtons. Now, part C, I'm actually just going to do this over in the corner, is a case of third law. And by that I mean we know that the tension pulling up on the frame will be equal to the tension pulling down on the helicopter. So the answers for B and C should be identical, but they will be opposite in direction. In other words, the helicopter would experience a force going down, and the frame would experience that tension force going up. That's number 81.